right, so let's look at a second way in which two events can interact, and that's with the union of events. And so the union of events is where the outcome of an experiment is within the union of events A or C. So the word or, whenever the word or is used between two events, we're talking about a union, or we can use the symbol, which looks like a capital U for union, in between the two events here. So here we're looking at the union of events A and C. In one case where A and C are disjoint, meaning they're not overlapping, and another case where two events are non-disjoint, meaning they are overlapping. And so if we're looking at the union of events A and C, and we're calculating the order of that, then it's going to be the order of A plus the order of C. So the number of elements in A plus the number of elements in C. If A and C are not disjoint, meaning there is some overlap, then the order of their union is going to be the order of A plus the order of C minus the order of the intersection. So it's going to be the order of A plus the order of C minus the order of the intersection in between. So where does this minus the intersection of the two events come from when it comes to counting the union of two events? So to kind of figure that out, let's look at an example of a single throw of one fair six-sided die where the sample space is going to be 1 through 6. And let's define event A to be 1, 2, and 3, and event C to be 3, 4, and 5. So the resulting Venn diagram looks like this. So we've got our sample space, and event A has 1, 2, and 3 in it. So we can see 1, 2, and 3 is in event A here in green. And then event C has 3, 4, and 5. So 3, 4, and 5, and event C is here in blue. So right off the bat, you can see that event A and event C have 3 in common. Okay, so they are not disjoint. They do have some overlap. So now let's look at events A and C separately, and then we'll look at the order of A and the order of C. So here's the order of A by itself here on the left-hand side. And on the right, we've got the order of C by itself on the right-hand side. And so if we just kind of look at the order of A by itself, we can see that there are 3 elements in A, right? 1, 2, 3. And you can see that here in the Venn diagram. Okay? Event A also has 3 elements. Event C on the right, okay, it has 3 elements. So the order of C is also 3. So if we incorrectly use simply summing the order of A and C together, then we get a union of these two of 6. But it's clear that A union C should be 5 and not 6. Because if we take event A, which looks like this, and we take event C, which looks like that, right? This is A and that's C. And we do a union, which means we combine their 2 areas, then it looks something like that. And how many elements do we have in the union now? What we've got is we've got 1, 2, 3, 4, 5. We've got 5 elements in the union, not 6, which is kind of like what we calculated here if we added them separately. So why does this happen? So the problem occurs when the number of items in each event were counted. The item 3 was counted twice. So up here, 3 was counted once, and then 3 was counted again a second time. All right, and that gave us an incorrect value for the union of two events being 6. So one time in A and one time in C. So this occurred because 3 was in both A and C. 3 was in the intersection of A and C. So the intersection was counted twice. So here I'm just kind of showing these two kind of superimposed on top of each other to show 3 being counted twice in each event, A and C. So therefore, when the union of two overlapping events occurs, one must subtract one instance of the intersection of both events. So when you're determining the order of a union of two events, you're going to take the order of one event plus the order of the second event and subtract the intersection ones. And you can see here the order of A is 3, the order of C was 3, and the order of the intersection is 1 because there's only one element here. And 3 plus 3 minus 1 gives you 5. And that's the correct answer. There are 5 elements in the union of A and C. 1, 2, 3, 4, 5. So finally, the order of the union of two events is equal to the order of the first event plus the order of the second event minus one of their intersection. So let's look at this example here. We're looking at the union of two events, one that's disjoint and one that is not disjoint. And this is based off a single throw of one fair six-sided die. So let's work on the left-hand side. So this is the case where the two events are disjoint. So A is going to be the event where a 1 or a 2 is rolled. C is the event where 4, 5, or 6 is rolled. Okay, this is the Venn diagram for this scenario, this experiment. So write the set of outcomes in A union C. So A union C is going to have 1, 2, so everything in A and everything in C. So 1, 2, 4, 5, and 6. So the order of A union C is the number of elements in it. So that would be 5. All right, let's look over here at a non-disjoint case. So A, we're going to define as being a roll of 1, 2, or 3. And C, we're going to define as being a roll of 3, 4, and 5. So you can see both A and C have 3 in common. So let's write the set of all outcomes of A union C. So that's going to be A union C. That's going to include everything in these two areas combined. So 1, 2, 3, 4, and 5. So here, the order of their union is going to be the number of elements in that union. That's going to be 5. Let me know if you have any questions.